Guys, welcome to my YouTube channel. Today we'll be discussing about Xilinx IC, which is used for Verilog, and also it is used for designing combination and sequential digital circuits at schematic level. So first part is installing Xilinx IC. So if you like do a normal Google search of Xilinx IC, you find this. The first download link you need to click it. My system is Windows 10, hence I'll download the archive for Windows 10 here. 14.7 Windows 7, Windows 10, and here is the download link. This download size is of 15 GB, so you might have to connect to a Wi-Fi for downloading it. Before starting with the installation, you will require this software known as the VirtualBox. Without installing this VirtualBox 7.0, if you try to install IC design suite, you will get an error actually, which I faced. So because the IC runs in a virtual machine, so you will need to download the VirtualBox 7.0 first. Okay, and after downloading, you need to install the VirtualBox 7.0. The VirtualBox will be like seen like this. Now this VirtualBox I've already installed, and it has the IC software running on it. After installing the VirtualBox, you can proceed with the installation of IC design suite. Okay, and after installing IC design, okay, I presume that you have installed Xilinx ISE, and once you open the Xilinx ISE project navigator from your desktop, it will navigate you to a virtual machine. From that Linux virtual machine, you just open project navigator by double clicking on this. Okay, it will open a default project. And let's create a new project from here using the new project button. I give it a name, let's say first project example. Next, finish. You have to create a new source from by right clicking on this file. Select a Verilog module, give it a name, SOP example. Next, don't specify any inputs and output because it would be done in Verilog code itself. Hit next and finish. Specify the inputs here. Let's say our module is accepting 3 inputs, A, B, C. All are 1-bit inputs. Okay, and it has 1 output, Y. And let's say we use the assign operator for specifying Y is a combinational circuit of let's say sum of products using not A. This is a not operator, and not B, and not C. Let's say the next expression is for 001. So I'll copy paste this and just remove the not get from C, and let's say Y is also equal to 1 for this case. 1 1 1. Okay, so I've completed this module using the continuous blocking or assignment for Y, and Y is equal to 1 for A is equal to 0 0, A B C is equal to 0 0 0, 0 0 1, 1 1 1. So once this module is completed, we check for syntax. We hope this, like the implementation tab should be by default clicked here. If not, then you should like click on implementation tab here and then check syntax. Yes, save it. You need to save this file using Ctrl S. Now syntax check is completed. We have no errors and warnings. So we now proceed to viewing RTL schematic. The RTL schematic consists of three inputs A, B, C, one output Y. The input ABC consists of AND gate and OR gate. Okay, so as you can see, like the input ABC have been optimized carefully from Xilinx ISE, and it is using the minimum number of AND gates and OR gate. So the bubble is used for NOT operator here. So here input is going as A bar to this AND gate. Similarly B bar, and then this NOT gate is joined to another. Then this AND gate is joined to another AND gate with input C bar, and it goes to the output Y. Similarly, here it is going to another AND gate, and this goes to an OR gate output. So this is how like the RTL schematic is in optimized mode here, which is using the minimum number of gates. But it can be like optimized further also, so which we'll discuss later. For now, like this is for the video, and let me know if you have any doubts in the comment section.